Welcome back. Example 16. Evaluate integral of secant power 5x dx. Notice this is an odd power of secant, higher than 1. This is a bit different from all the other cases we have seen so far. So, here we do the following. Use integration by parts. Secant to the 5, we will write it as secant cube times secant squared dx. So this part is going to be derivative of a function g. Okay, derivative of g is going to be secant squared. Therefore, g should be tan x and the first part should be f. So let f equals secant cube and gx equals tan x. Then f prime x, so that requires chain rule, 3 secant squared and derivative of secant is secant times tan. So in all, that comes to 3 secant cube x tan x. On the other hand, g, derivative of g is secant squared. That is what we wanted, right? Derivative of g to be secant squared. So now integration by parts. Integral fg prime is fg minus integral g f prime. So integral secant to the 5th power is integral secant to the 3rd power times integral secant to the 2nd power dx, which is f g prime. It is equal f times g, so secant cube times tan x minus integral g, that is tan x, f prime. F prime is 3 secant cube tan. So this is fine as it is, secant cube tan minus 3. This becomes secant cube tan squared x. Alright. Secant cube tan minus 3 secant cube tan squared itself, using an identity, it is secant squared minus 1. So notice this becomes secant cube tan x minus 3 integral, I have secant to the 5th power. Again, minus and a minus is plus 3 secant cube x. So notice we started with secant to the 5th power and our calculation resulted in something secant to the 5th power. So we are going to take this to the other side. 1 secant to the 5th power integral and negative 3. Negative 3 comes there, becomes positive 3. In all, 4 integral secant to the 5th power dx is secant to the 3rd power x tan x. This has been moved over there. So plus 3 integral secant to the 3rd power x. So notice I don't want 4 times something. So integral secant to the 5th power x dx is 1/4 of the right hand side. Alright. Now notice the question was to find integral of secant to the 5th power. We have reduced the problem to finding integral of secant to the 3rd power, which is a smaller power, but it is still an odd power of secant, and we will have to continue this process. Again, we will need to use integration by parts to evaluate integral secant to the 3rd power. Again, secant to the 3rd power, you may write it as secant to the 1st power and secant to the 2nd power. 2nd power dx is going to be derivative. 1st power is going to be fx. Second, secant squared x dx is g prime dx, which means g should be tan. Alright. So let fx be secant x and gx be tan x. Then f prime, derivative of secant, is secant tan and g prime is secant squared. That's by design. So integral f g prime is fg minus integral gf prime, which brings us to integral secant cubed x dx is integral secant x secant squared x. So that is f, this is g prime. By parts, you get f g secant x tan x minus integral g f prime. All right, f prime is secant x tan x. So multiplying all of this together, you get tan squared x secant x. So integral secant cube x is secant x tan x minus integral tan squared x secant x dx, which is equal secant x tan x as before minus tan squared itself is secant squared minus 1. So putting all that together, you have equal secant x tan x minus this together give you secant cube, integral secant cube, negative and a negative plus integral secant. So notice you had 1 secant cubed here and a negative 1 secant cubed here. So move this to the left hand side, you get 2 of those. So 2 integral secant cubed x dx is secant x tan x plus integral secant x. So we have reduced the power. But this integral, you know, this is a formula. Integral of secant x dx is natural log absolute value secant x plus tan x. So twice of integral secant cubed x dx is secant x tan x plus natural log absolute value secant x plus tan x plus a constant of integration. Bring the 2 over, so secant cubed, integral of secant cubed x dx is half of the entire thing plus a new constant. I call it c again. Okay, it's a new constant of integration. So you got secant cubed, integral of secant cubed. All we are going to do is place that integral here. So integral of secant to the 5th power x dx is 1/4 of something big. So write that down, 1/4 secant cubed tan x plus 3 times this quantity. So 3/4 times secant x tan x plus natural log absolute value secant x plus tan x, all of that in one big parenthesis, 3/4, and plus constant, you get a new constant. So you notice this is a long solution because secant is by itself in odd power. Okay, it takes some work to keep going. Let's look for one more example. What happens when you have secant to the even power? This is much easier. You don't need integration by parts. Even power, simply split out a secant squared. So integral secant to the 4th power x dx is integral secant squared x times secant squared x dx. This secant squared is nothing but 1 plus tan squared x. Why did we do this? Now you can simply use substitution. Let u equals tan x. Derivative of tan is secant squared. So this part, secant squared x dx, is du. And this part is 1 plus u squared. So integral 1 plus u squared du. Well, this is a straightforward polynomial. Integral of 1 is u. Integral of u squared is u cubed over 3 plus a constant of integration. Don't forget to substitute. U equals tan x. All right. So that took care of even power. Even power of secant by itself, it's quite straightforward. Now recall the following sum angle formulas, difference of angles formulas. Okay. Sine of a plus b is sine a cosine b plus cosine a sine b. Sine of a minus b is sine a cosine b minus cosine a sine b. Oops, that should be a sine. Cosine. Cosine of A plus B is cosine A, cosine B minus sine A, sine B. Cosine of A minus B is cosine A, cosine B plus sine A, sine B. Fine. Using these two, notice if I add the first two, these parts get cancelled because they are essentially the same quantities in opposite signs. They cancel out. And this doubles. So what does that say? Sine A cosine B is half of the sum of these two. Alright. Now sine A sine B. So that comes over here. So I need to I need to change the sign here, you see. So subtract cosine A plus B from cosine A minus B. When you add those two, when you subtract, you get twice of something. So sine A sine B is half cosine A minus B minus cosine A plus B. So make sure you check cosine A minus B minus cosine A plus B. That converts this to a positive, that to a negative. These two cancel and you get twice of that. So half here. On the other hand, cosine A cosine B, I just add these two guys. These two terms cancel out and you have twice of this. So half cosine A cosine B is half cosine A minus B plus cosine A plus B. Now this is very useful. Why? Well, we are going to use these identities to evaluate something like this. Sorry. Integral sine of 5x, sine of 4x dx. So you have product of two sines, different arguments. Well, fortunately, we have this formula. Sine is the middle one. So half of first minus second minus cosine of first plus second. So half of that. Okay, so that gets me, this is cosine of x minus cosine of 9x, integrals. Half outside, integral of cosine is sine minus integral of cosine 9x is sine 9x over 9 plus a constant of integration. Distributing the half fetches us the final result. So you see, sine. If the question had been sine and cosine, you would have used the first formula. If the question had been cosine and cosine, you would have used the third formula, and so on. So these three formulae are very handy. Next, now we start problems from web work. We'll continue these in our next video. Until then,